In this video, we are going to talk about polynomial functions or simply polynomials. Expressions of the type 4x cubed minus 3x square plus 5x minus 1 are called polynomials or polynomial functions. Here, x is called a variable and the powers of variable x 3, 2, 1, etc. are always non-negative integers such as 0, 1, 2, 3, etc. They should not be fractions. Hence, a polynomial, say 3x raised to 2 upon 3 plus 5x raised to minus 2 plus 3 are not polynomials. Polynomial in x is denoted by px, where p stands for polynomial. We will see more about this further. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. In polynomial px, 5x square minus 3x plus 2. This 5 is called coefficient of x square. This minus 3 is called coefficient of x, etc. The highest power of x, in this case 2, is called degree of polynomial. In polynomial px equals x minus 2, the highest power is 1, so its degree is 1 and it is also called linear polynomial. When the degree is 2, it is called quadratic polynomial. For degree 3, it is called cubic polynomial. For degree 4, it is quartic, and for degree 5, it is quintic, etc. In polynomial px equals 5x square minus 3x plus 2, if x is 2, then p2 will be 5 into 2 square minus 3 into 2 plus 2, that will be 20 minus 6 plus 2, p2 is 16. So the value of px at x equals 2 is 16. 0 of a polynomial is that value of x for which value of polynomial px is 0 if x equals a and pa equals 0, then a is 0 of polynomial px. Now how to find 0 of a polynomial px? For example, suppose px is 4x square minus 25. For finding 0, we will put px equals 0. That gives 4x square minus 25 equals 0. Factoring 2x minus 5 into 2x plus 5 equals 0, giving us x equals 5 upon 2 or x equals minus 5 upon 2. Now for x equals 5 upon 2, p 5 upon 2 will be 4 into 5 upon 2 square minus 25. That will be 4 into 25 upon 4 minus 25, giving us p 5 upon 2 equals 0, implying 5 upon 2 is a 0 of polynomial 4x square minus 25. So is minus 5 upon 2. So 5 upon 2 and minus 5 upon 2 are two zeros of 4x square minus 25. If x equals minus 2 is 1 root of x cube minus x square minus 17x minus 22 equals 0. We have to find the other roots. The degree of this polynomial is 3, which means this has at most 3 roots, out of which one is given minus 2. If one root is minus 2, then we will find the remaining 2 roots by synthetic division, for which we write this polynomial in the coefficient form 1, minus 1, minus 17 and minus 22. Then we write this minus 2 here. First we pull down this 1 and write down here minus 2 into 1 minus 2. Minus 1 minus 2 gives us minus 3. Minus 2 into minus 3, 6. Minus 17 plus 6 minus 11, and minus 2 into minus 11, 22, and minus 22 plus 22 gives us 0, and this 0 indicates the remainder. And the polynomial obtained from these 3 coefficients, 1 minus 3 minus 12, will be x square minus 3x minus 11. Now we have to factorize. X square minus 3x minus 11 equals 0. B square minus 4ac will be minus 3 square 9 minus 4 into 1 into minus 11, that will be 53. So square root of b square minus 4ac will be plus minus root 53. So by quadratic formula, x will be minus b plus minus b square minus 4ac root 53 upon 2a, which is 2 into 1, 2. So this will be 3 plus minus root 53 upon 2. And these are 2 remaining roots of this polynomial. Solve 2x plus 1 whole square minus 3x plus 2 whole square equals 0. The left hand side is difference of two squares, which can be factorized as 2x plus 1 minus 3x minus 2 into 2x plus 1 plus 3x plus 2 equals 0. This will be minus x minus 1 into 5x plus 3 equals 0, which will be x plus 1 into 5x plus 3 equals 0. First factor gives us x equals minus 1, and the second factor x equals minus 3 upon 5. So these are 2 roots of this quadratic equation. X square plus x plus 1 is a factor of polynomial 3x cube plus 8x square plus 8x plus a. We have to find a. By long division, we will divide 3x cube plus 8x square plus 8x plus a by x square plus x plus 1. 3x cube upon x square gives us 3x, that we write over here. Now 3x multiplied by x square plus x plus 1 gives 3x cube plus 3x square plus 3x, subtracting 5x square plus 5x plus this a. Now dividing this 5x square by this x square, we get 5, that we write over here. Multiplying x square plus x plus 1 by 5, we get 5x square plus 5x plus 5. Changing signs, cancelling, we get a minus 5. But since x square plus x plus 1 is a factor of this dividend, this remainder, a minus 5 must be 0, which implies a equals 5. Factorize x raised to 4 plus 1. We will factorize x raised to 4 plus 1 by completing the square. For that, we write x raised to 4 plus 2x square plus 1 minus 2x square. Now this is a perfect square, that we write x square plus 1 whole square minus, we write this 2x square as root 2x whole square. Now this is a difference of two squares, that we write x square plus 1 plus root 2x, the first factor, into x square plus 1 minus root 2x, the second factor. So finally x raised to 4 plus 1 will be x square plus root 2x plus 1 into x square minus root 2x plus 1. So these are the required factors. Now we will study methods of undetermined coefficients. In this method, we determine coefficients of terms of a required polynomial. In this method, we will use the property that when two polynomials p1x and p2x are equal, then coefficients of like terms of p1x and p2x are equal. Let us see how this method is used. Find a quadratic polynomial fx if f0 is 1, f minus 2 is 0 and f1 is 0. We will start by assuming the polynomial fx to be ax square plus bx plus c. We are given f0 equals 1, therefore 0 plus 0 plus c will be 1, c will be 1. Next is f minus 2 equals 0, so 4a minus 2b plus c equals 1 equals 0. That will be 4a minus 2b equals minus 1. We name this 1. Next we have f1 equals 0, which will be a plus b plus, in place of c we write 1, equals 0, which will be a plus b equals minus 1. We name this 2. Solving 1 and 2, we will get a equals minus half and b equals minus half. So this polynomial fx will be minus half x square minus half x plus 1. This can be found by another method also. F of minus 2 is 0 and f of 1 is also 0, which means that minus 2 and 1 are zeros of the polynomial, which means x plus 2 and x minus 1 are factors of fx. So we assume fx to be some constant k into x plus 2 into x minus 1. Now in order to find this k, we will use f0 equals 1. So f0 equals 1 gives k into 0 plus 2 into 0 minus 1 equals 1, minus 2k will be 1, k will be minus half. So the required polynomial fx will be minus half into x plus 2 into x minus 1 minus half into x square plus x minus 2. So fx will be minus half x square minus half plus 1. Construct a cubic polynomial function with rational coefficients with zeros x equals 2 upon 5 and x equals 1 plus root 3, such that p0 is minus 8. We know that the zeros of the type 1 plus root 3 always come in pairs, so the other zero will be x equals 1 minus root 3, its conjugate. Now that we have three zeros, we write the cubic polynomial px as some constant k into the first factor x minus 2 upon 5 into x minus 1 plus root 3 into x minus 1 minus root 3. For finding the value of k, we will use this fact that p0 is minus 8. So p0 equals minus 8 gives us k into 0 minus 2 upon 5 into 0 minus 1 plus root 3 into 0 minus 1 minus root 3 equals minus 8. So this will be minus 2 upon 5k into 1 minus 3 equals minus 8. So 4k will be minus 40, k equals minus 10. So the required polynomial, this one becomes, this will be px equals minus 10x plus 4 into x minus 1 minus root 3 into x minus 1 plus root 3, which is minus 10x plus 4 into x minus 1 whole square minus 3, which is minus 10x plus 4 into x square minus 2x minus 2. After expanding and simplifying, we get the required cubic polynomial as minus 10x cube plus 24x square plus 12x minus 8. Two polynomials, x square minus 6x plus a equals 0, number 1, and x square minus bx plus 6 equals 0, number 2, have one root in common, and their remaining roots are in the ratio 4:3. We start by assuming alpha to be the common root of these two equations. Now since the remaining roots are in the ratio 4:3, we assume roots of the first equation to be alpha and 4 beta, and that of equation 2 alpha and 3 beta. So for equation 1, product of roots 4 alpha beta will be c upon a, that is a upon 1 a. And for equation 2, product of roots 3 alpha beta will be c upon a, that is 6 upon 1 6. Now these two equations give alpha beta equals a upon 4 equals 6 upon 3, that is 2. That gives a equals 8. So equation 1 becomes x square minus 6x plus 8 equals 0. Factoring, we get x minus 2 into x minus 4, 0. So the roots will be 2 and 4. Now if common root alpha is 2, alpha beta being 2 here, beta will be 2 upon 2, that is 1. Here both 2 and 1 are integers. Secondly, if alpha is this 4, beta will be 2 upon 4 half, which is not an integer. So the common root, which is an integer, is 2. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.